Okay, now we'll see more closely to this particular thing called as, yeah, PES description of the task environment. Now this word, so far we were saying that environment, now this word says task environment. So what's the difference between it? So we assume that the agent, the way we are looking at the agent, it is in a conversation with the environment through the actions and the percepts. So it is something like doing a task. So whenever somebody gives you a task to perform, generally you have some sort of steps that you follow in order to complete the task. It's not a single go. Okay, the task generally requires you to do certain stages or certain steps में उसको solve करना होता है. So we assume that even the agent is working in such environment, which is like solving a task. That is why this is referred to as not just the environment, but the agent task environment. Generally, we assume that the agent working is like performance on a particular task at hand, and that's why we refer to it as agent task environment. Now this four things that we talked about even last to last lecture, PEAS descriptors. So there are PEAS descriptors who describe task environment. We give a more detailed description of the task environment. Why we want to have a detailed description of task environment? The reason behind that is to analyze the task environment in a appropriate manner, such that we will have insights while designing the AI based solution, or ultimately translating the agent into a agent program. Ultimately agent function मुझे चाहिए. एजेंट फंक्शन के लिए मुझे पता करना है पी स्टार का मैपिंग ए से, तो पी क्या है ये मुझे पता करना है. व्हाट इज परसेप्ट? Okay, to know what percepts are, I should know what sensor the agent has. What are the ways in which the agent is sensing the environment? Then I should know the actuators with which the agent is going to impart its updates to the environment state. Okay, so action से environment state update होने वाला है, इससे नए signals generate होने वाला है. So to have this cycle working, I should know what are actuators, what are sensors. I should know performance measure for the reason being able to be a rational agent. So if I want to be a rational agent, there has to be some measure to understand how good or how bad a particular action could prove in a particular situation. And to do this to do this particular analysis, I should know what is or how is the performance measure defined. Okay, ultimately the last thing I need to understand is the type of environment in which I work. So I should know different types of environments that generally are available for different kinds of problem domains. Once I know which type of environment a given task or given problem is into, I would have naturally a better understanding about what is going to be taken up from the actuators, sorry, taken up from the sensors, from the environment, how I model the environment state, and how do I go about doing the analysis of my performance and decide the requisite action. So to do all these things, we should be able to understand what exactly is PES descriptor. So given any task for which you need to build an AI, first and foremost thing, a good programmer or a good designer of AI system would do is first analyze the task properly, identify what are different performance measures, identify what is going to be actuators, sensors, and what are different types of environments. So that these are the things using which you do the analysis for your environment. Okay, so this is next slide. Did I miss something? There must be one more slide. Sorry. Yeah, so performance measure. Initially, when you are identifying performance measure, it should be the goals that you should identify. You should identify the goals that are there for that agent, and then those goals get translated into some numerical sense. So performance measure might not be always in some sort of objective numerical sense directly available to you. You need to formulate it, you need to identify it. So if I'm talking about an automated taxi driver, which is like a self-driver taxi, or automated, not self-driver, autonomous taxi for that matter. Okay, just customer needs to come to the taxi, he has to sit in the taxi, tell where he wants to go, and the taxi driver takes him, which is an autonomous car actually, an autonomous taxi. Then what could be the performance measure? So there could be different kinds of performance measure depending on where in this particular taxi is plying. Okay, if it is plying on a specific route like some tram or some kind of bus service works, like it takes you from one location in a particular city to some specific other location or set of locations, then my objectives or my performance measures will be different. If it is an catch here and go anywhere kind of a taxi, then my performance measures will be different. Again, with respect to different use cases and users, I may have different goals. Like I may want to have my person journey who is taking the journey to be safe. I want a person to transit from its source to destination location in a very fast manner and an efficient way. Okay, if usually it takes 20 minutes, I should be taking that person within 20 minutes to its destination. There should be some performance measures related to legal issues. If I'm driving a taxi, it is a taxi on the road, so there are some certain regulatory uh, issues that can arise when you are talking about such particular trips. Then it should be a comfortable trip and it should maximize your profit. So there could be different measures. These measures could be contradictory. So I may have a safe journey against the fast journey. I may have a faster route, but the route is not safe because there might be uh, traffic diversions, road conditions not being good on shortcuts, and many more things can be there. Or maybe fast can go against the profits, because if you take a particular person using a faster route, the faster route can be a tolled route, and if it is a tolled route, you are supposed to pay a higher toll, might be causing you to have less profits when you venture through such roads. Okay, generally when you have a tolled road, there are always certain kind of distractions, so you need to go to that road first, so there is a delay in reaching that road, and then you need to leave that road again to come back to your destination. So there are always delays at the end and the beginning of a tolled route or a faster route, so you might lose certain amount of your profits for giving those toll money, something like that. So that is what exactly the performance measures could be for a automated taxi driver. Problem. Next, what would be the environment in which this particular taxi driver is going to operate? It is the network of roads. Okay, then the other traffics which are adjoining this particular taxi. There might be another set of taxis in the same fleet, or other kind of vehicles which are running on the same roads or same traffic road networks. Then other traffic is going to be part of the environment, so they are going to impact him. So ट्रैफिक बढ़ गया, ट्रैफिक कम हो गया, आपका परफॉर्मेंस मेजर जो है वो चेंज होते जाएगा डिपेंडिंग ऑन दैट. द pedestrians who are crossing the roads in between, they are also part of the environment. The taxi driver, autonomous taxi driver, can't just hit a pedestrian when he's crossing the road. He has to stop, or he has to wait for the signals and other things. And the customers, especially the customer who is sitting in the taxi, he is also part of the environment. What could be the actuators? Actuators could be you could think of numerous kind of actuators, and at what level of details you want to view this particular autonomous taxi, depending on that, your actuators and sensors would be different. Okay, per se, in a generic sense, अगर मैं taxi driver example, autonomous taxi example ले लूँ, then my actuators would be the engine control, the control that is controlling the control software that is controlling the engine, then the steering wheel control, accelerators, brakes, signals, horns. These are all different types of actuators which are actuating on the environment. Okay, voice synthesizers and display screens. ये कहाँ से actuators आ गए? Because the system will talk back ना, whenever you are reaching your destination, whenever it is rerouting, all this information has to be conveyed to the customer. So there might be a voice synthesizer which is synthesizing some human like voice and giving it away to the customer. Then there has to be a display screen, maybe that is to interact. So display screen can be proved as a two-way communication channel nowadays. It can be an actuator or it can be also a sensor which is taking some inputs from the user. User is getting into the taxi and selecting source destination, source and destination, then his priorities, okay, what kind of roads he has to travel through, okay, major roads, minor roads, okay, he wants to travel to only through, say you are taking a journey from Kalyan to say airport, and you want to only travel with national highways, you don't want to travel with the state highways. These are all kind of restrictions, or these are all kind of inputs that the system wants to take from the customer, so it can be taken through some sort of a display screen. Nowadays display screen doesn't always use for displaying the things, it is also used for sensing the inputs. So there are kind of devices which can act as both actuators and sensors. That is what I mean. So sensors in this case may be cameras mounted on it because it wants to travel on the road, and there might be people crossing over, vehicles running in from all directions, vehicles crossing this particular vehicle, overtaking this particular vehicle and going ahead. So numerous scenes are there. So you need to have some sort of camera sensors, some sort of IR sensors for proximity, sonar sensor. Uh, you need to have speedometer to identify how much speed you are having. You must also have GPS sensor for navigation purpose. There could be some sensors like odometer and engine sensors and keyboards. A lot of different kind of sensors or input devices can be attached to this particular system. You can think of numerous things. If you go into the details, it will be a very big, I guess, kind of an answer. If somebody asks you that autonomous taxi driver ko kya kya lagega as actuators and sensors, okay, but it depends on how deep you want to study the particular problem. If your problem is going to be remain only for the purpose of, so you are solving maybe a part of the problem, that is, once a person tells me what is the source and destination, based on the traffic congestion and other things, I want to report a best possible path to reach the destination. So if this is the only part that you want to model as an AI system, okay, then the all other details are going to be missed. Okay, you won't be telling about the customer, pedestrian and other things as one of your environmental portions. Your environment then only be the road networks, the traffic status. Okay, these will be the part of the environment, but then users, customers and other things, they are off the records as far as the definition of environment is concerned. So defining environment can be done in different ways, in various ways, depending on how is the study going to be conducted on the given problem. So the things that we are learning, again I'm telling you this repeatedly, PEAS description is going to describe the task environment. So you need to know what task at hand you are trying to model as an AI system, and you need to restrain yourself, you need to restrict yourself to doing the analysis only for that particular task and not for a generic system. Generally when we write programs, we try to write programs which are generic, but here you need to be more specific. Okay, somebody can argue that with this approach you would give rise to an AI which is a weak AI, but then it would be more closer to the idealistic behavior if I concentrate on only the problem at hand or the task at hand. Okay, so there is always a counter argument, and in both the sides, the weak AI as well as strong AI. Okay, when you create a system which is like applicable to many different areas, then you might not do good in all the areas. You might be doing good in one of the application area, but that same system might not be up to the performance level for some other areas, but it can perform, it can solve the task. Okay. So this is another example which is called, which is a medical diagnosis system. So if I am talking to a chatbot, which is a medical diagnosis chatbot, okay, it can ask me my details like my name, the symptoms I'm actually having. Then it can ask me some questions based on my history, okay, history of illness, history of ailments that I had previously, history of treatments that I have gone through. Okay, these all are kind of now will be sensors or sensory inputs. Now these, please understand, whenever I'm saying sensors, it might not be always physical devices, right? Okay, so if I'm creating a chat bot which is a web application, okay, then this web application is going to take input through the user interface that it is showing to the user. So will you say that my sensor is that web application, that user interface? No, your user interface is not your sensor. Your sensor is whatever you are coming to you as input. So the entry of symptoms. So in this particular case of a chatbot, what is the sensor? The sensor input is the form that is filled by the customer or the patient in this case. So patient जो form fill करता है, वो जो details देता है, that is my percept. Okay, the sensor I'm using is maybe a graphical user interface which is generally given input through a keyboard or maybe a voiceover, whatever kind of thing. So कीबोर्ड लिखना यहाँ पे एक्चुअली एक्यूरेट नहीं होगा. सो यहाँ पे मेरे सिस्टम के लिए सेंसर्स क्या है, ये जो फॉर्म है, दैट फॉर्म इज माय सेंसर. द क्वेश्चनर दैट आई पोस्ट टू माय patient is what for me is my sensor. Okay, technically physical sensor is the keyboard because I'm entering the information, or maybe a voice over, तो मेरा जो mic है, that is my sensor. बट ये जो दोनों है, ये एक्चुअली कौन सा इंफॉर्मेशन मुझे दे रहे हैं, दे आर एक्चुअली गिविंग मी इंफॉर्मेशन ऑफ सम फॉर्म which is a previous record of the ailment, patient's history. So these are all a patient's answer to the question that the system has asked to the patient. Okay, so what symptoms patient has, what were the previous findings, what patient feels currently. Okay, so all this information is part of my sensors. Actuators क्या हो सकते हैं? Actuators in this case, the diagnosis system, यहाँ पे diagnose करना है ना, so I want to diagnose what ailment that the patient has. Okay, then after that diagnosis, I can actually prescribe maybe more questions. I can prescribe some test, I can prescribe some diagnosis, final diagnosis, or I can prescribe some treatment, or I can refer that particular person to some expert than the current system. So there are various ways in which I can have communication back to my customer in case of a medical diagnosis system. Okay, so I may ask multiple next questions क्योंकि ये chatbot का interface है. पहला question का answer आया, depending on what question I am asking, I'll ask another question, and this dialogue can prevail till certain point. At that point, when I have the enough insights into the current situation of the patient, and I have enough inputs for my model to diagnose the patient, I will come up with the diagnosis. Meanwhile, I may require him to do certain tests, so I may prescribe him those tests based on his situation, or I may prescribe him some alternate treatment patterns or treatment paths, or I may refer it to somebody else. Now, what could be the performance measure for a medical diagnosis system? ये वन परफॉर्मेंस मेजर इज कितने लोग उनका दुख भरा दर्द भरा सिचुएशन लेके मेरे पास आए और कितने पेशेंट हेल्दी हुए, कितने पेशेंट आफ्टर टेकिंग माय एडवाइस द मेडिकल डायग्नोसिस सिस्टम, कितने लोगों ने अपने डिसीज से इलाज पाया. Okay, how many people got relieved from their diseases based on the diagnosis that this system did. That might be the ratio of healthy patients. Maybe I want to actually have a system which can show alternative options to the user for treatment and minimize the cost of that particular treatment. So how much I was able to reduce the cost otherwise when the same patient would go to some other system and take the treatment with the same kind of symptoms. same kind of findings. Okay, the next thing is, were there any lawsuits? And this is very much there when it comes to replacing an expert in any domain with an AI system. Okay, हम लोग as a human being, we are very much actually concerned with our uh, personal rights and personal health, that there can be lawsuits that can be generated against the autonomous system. And it is very common nowadays about the medical system in general and the customers of medical system, people like you and me, to have some sort of lawsuits going around. So if there are any lawsuits that are getting generated, then that's a detrimental thing for my medical diagnosis system, autonomous medical diagnosis system for that matter. Okay, so this can be a counter effective measure. I want to minimize this, I want to maximize this. So healthy patient count I want to maximize. Okay, I want to minimize the overall cost that of the treatment to my customers or patients. Okay, so this way you can think of the